Hello Internet. Today we are going to be working on creating an asteroid belt. So our jetpacking VR game, our Asteroids VR, we need a ring of asteroids in that. And the idea is I'm calling it endless mode, but it's literally just going to be a ring of asteroids that keeps generating new ones as they come out of the view distance. And so pretty much you just work your way around the ring as long as you like, and that's that pretty much. So what we need to do is we need to come up with a way to simulate that, and it's going to be more complicated than I'd like. So there's a number of parts that we're going to have to do. What we're going to start with is we're just going to do a simple plane line, and this is going to be so really far away things. We're just going to have a plane here, and we're actually going to just crop this down so it's just a circle. And then based on that circle, we should be able to render at least a pretty simple ring and do that. And so we can use that for casting shadows onto our planet. And then we can also use it for really far away where you can't see the detail anyway. Obviously, it'll need to disappear when you get close. So that's what we're going to be working on here. That was a really long intro, but we'll get into it now. So what we have is a really quick surface shader. Pretty much all it is doing right now is shading the distance. So we're using this formula for the color, and so we're using the sine of our distance from our camera, which is calculated with this little formula up here, which is the difference between our camera's world position, our world position of our camera, and the world position of our current pixel, our fragment actually. And then we're taking that and just doing a sine wave over that. So we get this little pattern. We need that so that we can actually, the idea is we want to fade out pixels and not draw them at all if you're really close to them, because you are going to be in this field like this. And it looks really crappy when you can see that. So if you're anywhere near it, we don't want to draw it. We want to have like a minimum distance around you where nothing happens, and then we want an even further distance where things aren't, or where things kind of start fading in, and then when they're far away it'll look just solid. So hopefully that kind of captures hopefully it isn't jarring, but we'll have to play around with this. I've never done this before, so we'll see. What I want to start with is actually, let's shade based on our distance. We're already kind of doing that, but I would like to do it a little bit differently. So we're going to actually add in some fun parameters here. Let's do a minimum render distance. And so if anything is closer than this, we're just going to completely clip the pixel and not draw it at all. So we're going to do minimum render distance like that. And we'll give it a float, I guess. And we'll default that to 10. I'm using a really small thing, so that's going to be really big, but it's pretty easy to change, so we're going to work with that. And then we want a maximum fade distance. And so this is going to be where your fade in is going to stop. So between these two values is when you're going to actually fade in your shader. So this is going to be our maximum fade distance. And we can just type that out like so. Make it a float as well, and we'll make that 20 for now. Put some spaces in there because we need those. So if you're not familiar with surface shaders, I've done this a bunch in the past, but we'll walk through it again quickly. These are your properties. These are what are actually displayed in Unity to you. So you get this minimum render distance. This is the actual variable name you're going to be using. And this is like the friendly text you're going to see. And then this is the type, and this is the default value. So we should be able to compile this, and then in Unity's material editor, this is what we'll see. And then we need to reference it in our shader using this. And so since it's a float, we just need to add it down here. So add it as a parameter here. And then we can reference it inside of our surface shader right here. So let's add both of them. Do a maximum fade distance. Probably could have just copy and pasted. That would have been smart. Oh well. So we've got that. We don't need that. That was silly. What else do we need? Got that. So what I think the best way to do this is probably, well, first off, get rid of that. And then we can remove our color. That's not going to be needed. And instead we will have a fixed 3 of our color, and that'll just be fixed 3 0 0 0. So fixed, half, float, those are all floating point values, and each of them have different precisions. I don't know which is which. I should look that up, and I probably will do that after this video, but right now it isn't strictly relevant to us. So I'm gonna breeze past that. But that, if you see fixed and you see float and you see half, all of those are different things. They represent the same floating point numbers. They're just different precisions of floating point numbers. So depending on what you need, you pick that. So we have our albedo here, and we're just going to render that with our color. So this should just be black if I render this now. So we can actually break it. Our alpha we can set to 1. And so it'll just be totally opaque and it will be black. Like so. So we've got this random black chunk, which looks kind of meh. But we can change that. And so the idea is we want our color.r to be equal to what is it going to be? Distance greater than or less than, sorry, the minimum render distance. So if our distance is less than the minimum render distance, then we want it to be 1. Otherwise, we want it to be 0. So if it would be, if we don't want it to be drawn, I'm going to just draw it in red for now so we can kind of see what that looks like. And we get this red circle in our shader. So I can kind of move around and see what, based on the parameters we're passing in right now, I can see what won't be rendered. And we can kind of tweak things based on that. Since it's using albedo, the shader kind of, or the shadow kind of gets in the way, but you get the point. We can see now where things are happening. And so what I'm going to do next is I'm actually going to do a color dot. We have green and blue to work with, so let's do green, and we'll do I think clamp is a value you can do. So we're going to do our distance. Whoa. Distance minus the maximum. No, that's not right. Is it right? Hold on. So we need to get a range, calculate a range between here, between these two values. Yeah. So we need to see where our distance is in between these two values. So if it is there, then we can solve that by doing a distance minus the maximum fade distance and divide that by our maximum fade distance. No, this has to be our minimum, sorry. So I'll walk through this after I get this out because I am not able to think this through while I'm speaking. It's getting confused if you haven't haven't caught on yet. But anyway, we have our minimum render distance there. Put some parentheses in there. And then we'll clamp it between 0 and 1. Okay, so we get the difference between our distance and our minimum render distance. So this will be 0 if we're short. If we would be already culled, it would be 0. At that point, it will become not 0, I guess. And then we're dividing that by the difference. And then this can grow up to 1. So we should see, should go from red to black again, but then it should fade in a green value up to there. And so we should see it go, ooh, compile error. Oops. What did I do wrong this time? Probably a lot of things. Oh, semicolon. Those are important. If you don't do those, then everything blows up in your face and it's still wrong. And I spelled things wrong, so this is going well. All right, minimum. Yeah, there we go. Spelled it right. And we do get the green. So we're seeing exactly what we expect. We get this red will not draw ring, and then we fade in our green. And so this can be kind of our opacity almost of our multiplied opacity. And then this red can be our clipped values. So let's actually do that. So for our red, instead we can just take the color out and just do clip and plug things in like this. So clip is going to draw a pixel if it's greater than 0. And if it isn't, it will just skip that pixel. It will discard it. So if this distance is less than the minimum render distance, we want to do that if our distance minus the minimum render distance. So it's going to take the current distance from that pixel, from that fragment, and it's going to subtract the minimum render distance. So that'll be negative. It'll be a negative value if it's too close, which means it's not going to draw. So if we start this now, you can see those, we can actually see stars there, and those pixels are all gone, which is what we wanted. So we don't get the red anymore, but we do get a giant hole in our mesh, which is good. It means things are working. So now we can take this green and use it as an opacity. So let's do a fixed opacity like that and plug in our opacity as our alpha value. I don't think this is going to work, but that's a totally unrelated issue. So we can plug that in. And yeah, so this is still broken, but it's not broken because our script is wrong. It's broken because we have not made this an alpha shader. So when you're making something transparent, it needs to be rendered entirely differently. And that kind of breaks a few things. So transparent shaders are rendered afterwards. They're rendered after the rest of your scene is rendered because there's a depth shader, or there's a depth buffer that is used by the GPU to say, we've already drawn this pixel and it's closer than the one you want to draw, so don't draw it. If you do transparent things, if they write to that depth buffer, it doesn't work anymore because you just put a depth in, but you have a transparent object. So things may not draw behind it. So it can kind of unintentionally cull your stuff that you may not want to happen. So we have to kind of be a little bit careful with that. And so you have to actually tell Unity, hey, render this transparently. So let's do that. I think you just call it an alpha there. Yeah. And so if you define it as an alpha shader, you can see it's doing sort of what we want. It's a little bit less nice than I like. As you can see, there's some significant cutting in, like you can tell exactly where it starts and where it ends. We want this to be a smooth transition. So let's smooth that out. let's multiply that by our opacity. And I don't think that's going to solve it, but it'll help, I think. No, that just made it worse. One sec, actually, I want to go and check out some documentation and see how to do this, because it's been a while. I know we can use, there's some fading techniques that they have, so you can like do additive blending and stuff. We don't want that. We want this to feel solid. We don't want it to be like added on top of our scene and shiny. So I'm going to try to figure out how to do that correctly. I'll be right back. Okay. I got it. I think I got it. Here. Okay. So here's how we did that. I had to do a bunch of stuff and a bunch of tinkering. But anyway, what we have is we have these tags. This was supposed to be done earlier. It was kind of in reference to what I was doing. We want to ignore projectors, which is a Unity feature that can project a material onto something. We don't want that to happen here. We have our queue, which is which queue it's actually a part of. By doing this, you're saying render this is part of this is a transparent object. You're telling Unity what it is. And then we're just specifying the render type as transparent as well. But what we actually were looking for was actually setting the alpha to fade, which took way longer to find than it should have because it was on their main documentation page. I just didn't look there first. But anyway, now that that's there, we have this, which I can modify slightly. So we'll bring this down to, let's say 2, and bring this down to, say 3. And so I can get actually very close. Make it a little bit more subtle, but I can get pretty close to this. And it's selected so you can't tell, but there's nothing there. You can see through it, which is fantastic. So there's a few other things we need to fix. One of those is there's nothing underneath it. So we could just do this and just rotate this vertical, or that's not how we wanted to do it. Like that, I believe. Yeah. So now we've got a plane, but that is silly. So we're not going to do that. What we can do is we can actually modify our shader. So there's a way to actually have this not be culled. That's what this is it's getting culled. We played around with this with culling a bit in a previous video. I can probably drop a link in the description if you're interested in that. We're working on mesh deformation and generating meshes. So what we can do here is actually just turn that off. And so you can just come up here where it's got all of these. It doesn't really matter where it goes. You just have to say cull off. And now if we go underneath, ta-da! So we now have successfully disabled culling on the bottom and the top. So it's working as intended. And everything is great. So now the only other thing we really need to work on is we need to make it a ring, which we can do because we have these UV coordinates, which are going to be between 0 and 1. So 0.5, 0.5 is going to be the center of our mesh. This is one of like the original videos that was on this channel, but we can play around with that and do some clipping based on that. So we are going to do a float 2 of our position, which is going to be float 2 of 0.5 minus our input.uv of our main texture, and we'll do our x coordinate for that. And we can copy that again and subtract the main texture.y. We could also do like some other calculation to get this. It doesn't particularly matter. We just need it to be between 0 and 1, so we need to divide these UVs, because they're between 0 and 1, by 2. And then we can actually render that out, because why not, as our position.x and our position.y. So it'll be red and green, or broken. To the left of UV. Oh, that's not how you do that. UV underscore main texture. No period needed. Okay. And so we have red and green, and then yellowish, and then blackish. And so this should be our plane. It should go through everything. If it doesn't, then we did something wrong. But it still disappears, does all that cool stuff. But now we can use these and actually calculate the distance. So this can just be done in a basic trig thing. And so if we just plug this in as a clip of the square root of our position.x times position.x plus our position.y times our position.y. And that's just Pythagorean theorem. It's x squared plus y squared. And so as long as that is greater than 1, no, greater than our ring distance, which is going to be between 0 and 1. So we need to actually specify that. Let's do inner ring diameter. And that's going to be our inner ring diameter, like so. And then we can plug that in as a range between 0 and 1. So if it has an inner ring diameter of 0, it's just going to be a flat thing. So it's going to be more or less a circle. But if you give it something else, you can actually put an inner circle where nothing is drawn in there. We'll give it a default of 0.5, I guess. Why not? So we have that. Can actually use that now. Well, no, we can't. We have to first add it here. There we go. Now we can use it. So if we plug that in and subtract it here, as our inner ring diameter increases, we're going to be culling more and more, because we're going to be subtracting off more and more values, which are going to be falling below 0 and getting clipped. So the only other part we have to do is actually use that distance again. So we're going to save that out as our function there, and we're going to call it our ring distance from center. It's a rather long name, but okay. And so if we do the distance from center in here and do 1 minus that, if it ever exceeds 1, it's going to get clipped. And so that way we get the outer part and the inner part. So we should, oops, did I forget? Yep, semicolon. So let's do this again. Oh. Oh. That's not right. So I broke it. Oops. Good news. I was right about it turning into a plane again, but our values are wrong. I should have noticed this, because I was expecting green and green, and or green, green, red, red. Yeah. So let's actually drop that down so we can continue testing. And what did I do wrong? That's a great question. So between 0.5, that, oh, ha, I got it. This isn't what we wanted. We wanted 0.5 minus that times 2. And we wanted these in the parentheses, like so. So this is going to get us between 0.5 and negative 0.5. Then we multiply that by 2 and get between -1 and 1. And that way, we actually get the thing we were looking for, which means since things are between 1 or -1 and 1, they have the proper length, and things are actually getting properly culled, like our circle logic is now working. And this should now work. Yeah. So now we have a ring. The only issue is the color is a little bit funky. And you'll also notice our shadows are broken. And this is because we are not really rendering them correctly. You can't render shadows correctly with what we're doing. So we're actually going to have to turn shadows off. So I'm actually going to remove that full forward shadows. We don't need that. We actually aren't going to want shadows at all from this. So I'm going to turn that off as well. We'll need a separate shader that just does the ring, no fading or anything. And we can use that for shadows. And it won't draw anything. It will just draw the shadows. But this is what we're stuck with. So there's no cool shadows, unfortunately, but it's still actually, we still wanted the full forward shadows because we still want shadows to fall on our ring, which I don't know if that'll still work because I had issues with this in the past, but we're going to try that. I've been rambling. Let's not do that anymore. Let's solve this ring problem. And the ring problem I'm describing is we need to actually texture this. I have a texture here that's just relatively basic. You won't be able to tell what this is because it's only 1 pixel high. But the idea is it represents a density map of asteroids around here. And so we can use that to actually draw here and actually draw that. And we'll take some separate texture to actually texture it, but this will be the density. So this will actually represent the opacity within this little ring. So let's bring that in. We'll call it the density map, like so. And it'll be a 2D texture, and we'll default it to white, so it's just all asteroids, which probably isn't ideal, but oh well. And then we will save out our density from our texture into a variable, and we'll call it our density map, like so. Take the input, and we can actually reuse the main texture's UVs, like that, and we don't need to multiply it by any other value. The only thing we do need is to actually reference it up here, like so. And so now I'll separate these out a bit because it's getting a little bit hairy. So we have a bunch of clipping, our color, which I think I can pull out, yeah, and put down here. Okay, and then what we need to do is actually use this density to multiply our color. Or just set our, no, that won't work. Ignore me being crazy. We need to take our density map and plug it into our albedo, the color that we're actually giving off. That doesn't really work as well. Like here, I'll show and tell. If you put in the density here, the density dot RGB, it doesn't really do what we expect. So we're getting white, which also isn't what I expected. Interesting. Huh. Oh, duh. That's not gonna work because we didn't apply it. There we go. That looks a little bit more normal. It's going to be very dark because the entire texture is black and we just use the opacity. So let's actually do that. Let's plug in our color, which is here. And then for our red, green, blue, for our blue, let's use our density.a, our opacity. So things will be blue if they are transparent. And you can see we've got rings-ish. So the idea here is we don't want this to happen. We want them to go only across this ring here. And so our texture lookup, where was it? Up here, shouldn't be up there. Instead, we want it down here. And we don't want to actually use these UV coordinates. We want to use a new float2 with a clamp, and we want to get our... Does our opacity actually solve that already? I think it might. Yeah, it will. So we can actually just reuse our opacity, and we can plug in any value we want for the V coordinate because it's just 1 pixel, so it's not gonna, we're not gonna miss anything. Well, actually, to be explicit, let's do 0.5, so it's actually in the center. Our opacity is going to be the distance between inside of that sphere, or the ring, and it's going to be 0 if it's on the inside and 1 if it's on the outside. And so we can actually use that. Ooh, no we can't. We need a semicolon. Where did I know you're there. Come on. Come on. Come on. No? Okay. What am I missing? Did I totally screw something up? Oh, yes. Parenthesis, not a semicolon this time. There we go. And so if we get really close, oh, it's based on distance from our camera, not distance from that. Okay. Right, we need a similar formula but different. So we can see the rings are popping up in our distance from it, which is not what we wanted. Oops. But we get the idea here. So we get these rings going out from us. So we want to change that formula so that it actually is based off of the distance from the planet and the ring radiuses instead of distance from ourselves. And we should be able to do that. So we can actually copy and paste this down here. And then use the ring distance from center calculated there. And then the inner ring diameter for the minimum. And then 1 for the maximum, because that's our maximum. And then we're clamping between 0 and 1. So we should get rings. Yeah. Like that. Cool. So I'm going to reduce this so things stretch out. You can kind of see it better. But we now have very psychedelic rings, which probably don't look like that cool, but we don't actually want them as the color. We want to multiply the opacity by the density there. So what we're doing is taking, where was it? We want to, so our opacity or our fade out as you get close to it, we can actually use that based on our density as well. Use the alpha there. And then we get these really cool effects. So now we have rings, and you can actually see through them if you are in the right spot, and they look ringy. And yeah, I think that's a nice place to probably stop. They're still psychedelic. They're still very much space rings on shrooms, but at the same time, space rings. And as you get close to them, they kind of fade out, and they fade out smoothly. So this doesn't look great right now, but that will change as we actually fade in asteroids as you get, so all of this extra faded out space, eventually that's going to be filled with actual asteroids. So we're going to actually pull those in as you get closer. But this is just sort of the long range run. So I think next we'll probably work on getting a shadow back onto our planet, because I think that looks sweet. And then after we do that, we can start working on making this less trippy. So we'll see where that goes. I think it'll be fun. So if you guys enjoyed it, let me know in the comments. I'd love to hear what you're thinking, and if you've got ideas on where we can take this or ideas on how to do it differently, I'd love to hear them, because this is just my solution. So if you've got something better, I'd love to hear it. If there's something you guys want me to change as well, I can do that as well. So let me know. But until next time, see you, Internet.